Okay, elimination part one was to eliminate the variable that had the coefficients that were opposites. Now sometimes that doesn't happen and we need to multiply one or both of the equations in order to solve. So for elimination part two, sometimes you may need to multiply one or both of the equations in order to eliminate a variable. We're going to do a couple of them where you're going to just have to multiply one of the equations, and then we'll do two of them where you have to multiply both of the equations in order to create those opposites for the variables in order to eliminate. So let's try our first one. Okay, so we have example 1. We have 8x plus y equals negative 16. And we have negative 3x plus y equals negative 5. Okay, so we're still going to be adding these two equations. Okay, that has not changed. However, you need to look to make sure you've got opposites. Okay, so we know in front of these y's, it's the magic number 1. So if I'm looking at my x variables, I have an 8 and I have a negative 3. So right now, there's really nothing I can do with those two. However, if I look at my other variable, my y, they are both have a 1 and they're both positive. So I just need to make one of those negative in order to be able to eliminate it. So I'm just going to choose my first equation. How can I make a positive 1 a negative 1? By multiplying. What can I multiply 1 by to get a negative 1? And that's going to be a negative 1. But here's the thing. Put parentheses around the entire equation and put the negative 1 next to it. Because you are multiplying the entire equation by negative 1, not just the y variable. So this now becomes negative 8x minus 1y, I'll put the 1 in there, equals negative 1 times negative 16 is a positive 16. And then my second equation, I'm just going to bring over as it is. Negative 3x plus 1y equals negative 5. Now I have opposites for my y, so I can go ahead and eliminate. So they cancel. Negative 8 plus negative 3 is negative 11x equals positive 11. Divide both sides. I get x is equal to negative 1. So I know that I have to substitute, and this is where it's important that you go with one of the original equations. So I'm going to use 8x plus y equals negative 16. Substitute. So my x is negative 1, so 8 times negative 1 plus y is equal to negative 16. 8 times negative 1 is negative 8, plus y is equal to negative 16. I'm going to add 8 to both sides, and then I'm going to get y is equal to negative 16 plus 8 is negative 8. Therefore, my coordinate pair is negative 1, negative 8. Okay, we'll do another one like that. Example 2. We have negative 6x plus 6y is equal to 6. Negative 6x plus 3y is equal to negative 12. Now I can't really do anything with y because they're different values. I have different coefficients. However, if I look at my other variable, I have both negatives. So I know if I make one of those positive, I can cancel out the x variables. So I'm going to do the second equation this time, and I'm going to multiply it by negative 1. So negative 6 times negative 1 is positive 6x minus 3y equals positive 12. Multiply every part of the equation. Bring over my original from the top equation. Negative 6x plus 6y equals 6. Now I'm going to treat that as an addition problem. My x's cancel out. 6y and negative 3y is equal to positive 3y. And 6 plus 12 is equal to 18. Divide both by 3. Y equals 6. Now I'm going to choose one of the two equations that I started with. So negative 6x plus 6y equals 6. So I have to substitute in. So I'm going to keep my negative 6x plus 6 times 6 equals 6. Negative 6x plus 36 equals 6. I'm going to subtract 36 from both sides, and I get negative 6x equals negative 30. Divide by negative 6. X is equal to positive 5. So therefore my point of intersection is 5, 6. All right, that's what happens if you only have to multiply one of the equations. But sometimes you're going to have to multiply both equations in order to find the point of intersection. So example 3, we've got 5x plus 2y is equal to 8. 3x minus 5y is equal to 11. All right, if I look at my x's, the coordinates are different. If I look at my y's, the coordinates are different. Okay, so we rule out that. Now I want to see, do I have either one of my variables that one is negative and one is positive? And that would be, yeah, my y's. One is positive and one is negative. So I can eliminate my y's. But they need to be the same number in order to eliminate it. So that means I need to multiply both equations by a number that's going to bring me the same coefficient. All you need to do is flip the order. So if I have a 2 here, then I'm multiplying this by 5, which is right here. If I have a 5 here, I'm going to multiply this one by 2. I want to eliminate y, so I want to multiply 2 times 5 and then 5 times 2. So both equations, 5 times 5 is 25x. 2 times 5 is 10y. And 5 times 8 is 40. 3 times 2 is 6x. Negative 5 times 2 is negative 10y. And 11 times 2 is 22. Now we're going to add them. They cancel each other out. I have 25 plus 6 is 31x equals 40 plus 22 is 62. Divide by 31, divide by 31, x is equal to 2. Now this is important that you go back and substitute into one of the original equations. So I'm going to take the first one, 5x plus 2y equals 8. I have my x, so it's going to be 5 times 2 plus 2y equals 8. This is not new, you guys should know how to do this part of it. Okay, I'm going to subtract 10 from both sides. I'm going to have 2y is equal to negative 2. Divide by 2. Y equals negative 1. So it should be 2, negative 1. That would be my solution. Okay, one more fast one here. If I have example 4, we have 4x plus 3y equals 1. 5x minus 4y is equal to 9. Again, I have opposites here. I cannot do anything with the values the way that they are, but I do have opposite signs for my y. So for my first equation, I'm going to multiply by 4 because I want to eliminate these and they have to be the same number. So my bottom equation, I'm going to multiply by 3. So all I did was multiply by the opposite number. So I'm going to get 16x plus 12y equals 4. And then I'll get 15x minus 12y is equal to 27. Now I'm set to go. Eliminate. 16 plus 15 is equal to 31. And 27 plus 4 is also equal to 31. Divide by 31, x equals 1. I'm going to choose my first equation again to substitute to find my y. So 4x plus 3y equals 1. 4 times 1 plus 3y equals 1. Subtract 4 from both sides. I would get 3y is equal to negative 3. Divide by 3, y equals negative 1. So my point of intersection would be 1, negative 1.